Right now, somewhere beneath the deserts of East Africa, the ground is tearing itself apart, and scientists have just confirmed something that sounds like science fiction. A brand new ocean is forming, live in real time, and researchers can now measure it, happening beneath their feet. This is not a theory anymore. This is not a distant hypothetical drawn on a textbook map. Scientists have found an actual oceanic crust, the same dense rock that exists under every ocean on Earth right now, forming beneath a crack that stretches for thousands of kilometers across Kenya and Ethiopia. And the process driving it is not slowing down. New research says it is happening faster than anyone previously predicted. To understand what is happening, you need to go back to one single terrifying morning in 2005, in the scorching desert of the Afar. Region in Ethiopia, one of the hottest and most inhospitable places on the entire planet, the ground simply split open. A crack more than 35 miles long tore across the landscape in a matter of days, something geologists normally expect to unfold over centuries, not compressed into a single week. That event was the visible surface signature of something enormous happening deep underground. Beneath the Afar region sits one of the strangest and most important geological locations on Earth, a place scientists call a triple junction. 3 tectonic plates meet there at once: the Nubian Plate, which carries most of the African continent, the Somali Plate, which carries the eastern coast and Madagascar, and the Arabian Plate to the north. All 3 are being pulled apart from each other at the same time, in 3 different directions, like a piece of paper being torn by 3 separate hands. This entire system is called the East African Rift, and it has actually been developing for more than 30 million years. But what has scientists newly alarmed, or at least newly fascinated, is how much faster certain sections of it are now behaving compared to what older models predicted. The section getting the most attention right now is called the Turkana Rift, a roughly 300-mile wide zone straddling the border Kenya and Ethiopia. New research published this year in the journal Nature Communications found that this stretch of crust is undergoing something geologists call necking, a process where the Earth's crust gets stretched thinner and thinner, almost like pulling taffy, right before it eventually breaks through completely. According to the study, this is the only known active rift anywhere on the planet currently caught in this specific critical phase, giving scientists a front-row seat to a process that shaped every single ocean basin that already exists on Earth today. The numbers behind this stretching sound small on paper, but they add up to something massive over time. The plates in this region are separating at roughly 1/5 of an inch per year, or about 4.5 millimeters. That is barely the thickness of a coin, but tectonic plates do not need speed. They need time, and geological time operates on a scale that makes human history look instantaneous by comparison. To put that necking process in more visual terms, imagine slowly pulling apart a thick slab of dough. At first it just stretches, staying connected across its whole width. Eventually, the middle gets thin enough that it starts to sag and weaken faster than the edges, until finally it tears through completely, leaving 2 separate pieces where there used to be one. That is essentially what is happening to the crust beneath the Turkana Rift right now, just over a timescale of millions of years instead of minutes, and with molten rock filling the gap instead of open air. Researchers studying this exact stretch of crust noted something else striking, that different published models of how this region will ultimately behave do not fully agree with each other. Some predict straightforward opening, similar to what is happening further north. Others suggest sideways sliding motion instead, and a few even model compression in certain spots rather than stretching. That disagreement itself is telling. It means this stretch of the rift is more structurally complex than a single simple line splitting apart on a map. And scientists say more direct measurement in the region is still needed to fully resolve exactly how it behaves. Here is where it gets genuinely strange. Researchers studying the mantle beneath the Afar region discovered that the molten rock rising up from deep inside the Earth is not moving in a smooth, constant stream the way scientists long assumed. It pulses. Scientists compared it to something like a heartbeat, distinct waves of partially molten rock rising in bursts, each one carrying its own unique chemical signature, and each pulse getting funneled and shaped by the rifting plates directly above it. That discovery matters, because it means the breakup of a continent is not simply a slow, passive stretching process happening on autopilot. It is being actively driven and accelerated from below by surges of heat and molten material pushing up from Earth's interior on a rhythm scientists are only just beginning to understand. Every one of those pulses is a candidate trigger for the next visible surface event, whether that shows up as a new volcanic eruption, a sudden earthquake swarm, or another crack tearing open across the desert floor the way it did in 2005. So what actually happens next in terms of real, visible, surface-level activity? The Afar region and the wider rift zone remain one of the most volcanically and seismically active places on the planet, and that activity is a direct symptom of the pulsing mantle beneath it. Earthquake swarms in this region are common precursors to dike intrusions, events where magma forces its way directly into a crack in the crust and solidifies there, widening the rift by a small but permanent amount each time it happens. The 2005 event itself was exactly this kind of dike intrusion, just on an unusually large and sudden scale. Scientists monitoring the region expect more of these episodic bursts going forward. Not a smooth, continuous process, but a stop and start rhythm of relative quiet, punctuated by sudden, sometimes dramatic events, each one nudging the rift a little closer to a full breakup. Predicting the exact timing or exact location of the next major dike intrusion or earthquake swarm remains extremely difficult because the system depends on where the next mantle pulse happens to surface. The wider East African rift is already lined with some of the continent's most historically active volcanoes, and researchers use that existing volcanic record as a rough guide for what future activity might look like. Ground swelling, gas emissions, and small earthquake clusters have preceded past dike intrusions in this region, giving scientists at least some early warning signs to watch for, even if the exact moment of rupture remains hard to pin down in advance. Modern satellite monitoring, using radar to measure ground deformation from orbit, has made it possible to track this kind of subtle swelling with far more precision than researchers had even a decade or two ago, which is part of why this region is under closer scientific observation now than at almost any point in its history. Now, for the part that sounds almost unbelievable but is treated as essentially inevitable by geologists. If the rifting continues at anything close to its current pace, the Red Sea and the Gulf of Aden, both of which already sit right at the edge of this same triple junction, are expected to eventually flood directly into the Afar Depression and pour into the East African Rift Valley itself. Salt water from two existing bodies of ocean pouring inland to fill the gap left behind by a splitting continent, creating an entirely new ocean basin in the process. When that happens, and researchers are now treating the when as more certain than the if, the African continent, as we currently know it, stops being one landmass. The Somali Plate, carrying a long strip of eastern Africa along with Madagascar, would drift away as its own separate continent, while the much larger Nubian Plate carries the rest of Africa in the opposite direction. A marine geophysicist studying this long-term outcome describes it plainly, this section of East Africa evolving into its own genuinely distinct continent, separated by open water from the continent it used to be attached to. The geography this would eventually create is almost hard to picture. Countries that are currently landlocked, with no coastline at all, places like Rwanda, Uganda, Burundi, the Democratic Republic of Congo, Malawi, and Zambia, would suddenly find themselves sitting on the edge of a brand new ocean, with direct access to build ports and harbors, connecting them to global shipping for the first time in their history. Kenya, Tanzania, and Ethiopia would each end up split across two separate landmasses entirely. Before anyone starts picturing beachfront property, it is important to be completely clear about the timeline here, because it is the single most misunderstood part of the story. Current plate separation rates put the full formation of this new ocean somewhere between 5 and 10 million years away. This is not a countdown clock ticking toward next year, next decade, or even next century. It is one of the slowest, largest processes the planet is capable of, and the timeline is measured on a scale where entire species rise and vanish before it finishes playing out. But here is why scientists studying this are not just treating it as a curiosity for the distant future. The process is driving toward that eventual ocean. The earthquake swarms, the dike intrusions, the volcanic activity across the rift zone are already actively happening right now in the present day. They carry real consequences for the millions of people who currently live across this rift zone. Understanding exactly how and when the next dike intrusion or earthquake swarm might strike has genuine value for earthquake hazard prediction and public safety planning in the region today, regardless of how many millions of years the final ocean takes to fully form. There is also a remarkable side effect of all this tectonic violence that has nothing to do with future oceans at all: the volcanic activity that helped kick off this entire rifting process. Millions of years ago also happened to preserve an extraordinary fossil record in the same region, more than 1,200 discovered hominin fossils, spanning roughly 4 million years of human evolutionary history. The same geological forces splitting a continent apart are the reason scientists have such a detailed window into humanity's own deep past, layered directly into the rock of the rift itself. It helps to zoom out and compare this to what Earth has already done before, because this is not actually a new kind of event, just a rare chance to watch one happen in something close to real time. Every ocean currently on the map today, the Atlantic, the Red Sea, the Gulf of California, began exactly this way, as a slow continental rift widening millimeter by millimeter until seawater finally found its way in. The South Atlantic Ocean itself formed when South America and Africa tore apart from each other in a process geologically almost identical to what is happening in the Turkana Rift today, just separated from us. Now by roughly 130 million years instead of unfolding live in front of modern instruments. If you find it wild that scientists can now watch a brand new ocean forming beneath a continent in something close to real time, make sure you like and subscribe, because this channel exists to break down exactly this kind of planet-scale science before most people even hear about it. So here is where things actually stand right now. Africa is splitting apart, confirmed, measured, and actively monitored. Not a distant hypothetical anymore. Oceanic crust has already been detected forming beneath the rift, a milestone scientists say has never been observed at this particular stage anywhere else on Earth. The mantle beneath it is pulsing in rhythmic surges that will likely keep triggering earthquakes, volcanic eruptions, and sudden new cracks for millions of years to come, each one a small, unpredictable step toward an ocean that has not existed yet, but that the geology says is coming regardless. The only real question left is not whether it happens, but which pulse, which earthquake, which Quiet Tuesday in some future century ends up being the next visible chapter in a story that has already been unfolding for 30 million years.